Today we are going to be talking about two important frameworks in data engineering. And then the reason why we are building this is to support enterprise to maximize the value of their data investment. And then maybe that way they'll be able to maximize the customer benefit. So what we are trying to learn is important. It helps a lot of companies to think about how they process data, how they consume it in a way that is actually really useful and then cost efficient. So a little bit about me. I think Victor has done like a very detailed introduction about me. I think the highlight is just that I'm a data engineer and I'm an enterprise architect. And my philosophy is that we should keep things as basic as possible. Things needs to be like really, really basic. If it's basic enough, that's when we can build complicated layers on top of it. And then the second philosophy about data is that data is actually an asset by companies. I think everybody's getting to like realize that now. I have 5 years experience in data. I've worked as analytics engineer, data engineer at First Bank. Now I'm starting to lead a team in the UK, Tier 1 bank. So I have like a little bit of experience in regards of data engineering. So you can connect with me on these platforms. Yeah, so let's just leave it as that about me. Let's look at what we want to talk about today. So what we are going to be talking about is that I'm just trying to like let us reflect more about ETL and ELT frameworks. And then we'll also look at, okay, what are the considerations that we need to look about when we are trying to implement either of these architectures or frameworks? Then how do we even make good decisions based on experience, right? So and then we take some questions. So it's really going to be a very short conversation, but very basic. As I said, I really don't like when things is like really, really, really complex. So here is the thing. I would like to start with this. That it's easy for us to say these two guys, Messi and Ronaldo, has actually been like, okay, which one is your goat or something like that. It's easy for us to make that decision as a football lover, right? Or when we are the coach, that the performance, the output of these personalities really, really impact our work, besides our future or something like that. That is, we're actively involved in the result as a coach, right? We begin to consider those things and say that, okay, not just beyond we following the trend, we actually need to consider something clearly. That is the case with ELT and ETL. It's easy to say that, okay, yeah, it is trending. ETL is the one that I'm very grounded in, all of those things. It's easy to make that kind of decision as when you are building projects, when you are learning. But when you enter into a corporate environment, an enterprise, so you're actually implementing those things. So you're actually involved in the game now. Every decision that you actually make really impact you and the business one way or the other. Then you begin to think differently. You might now be considering that, okay, do I need a playmaker? Do I need a goal scorer? Do I need someone that can carry the fans along? All of those things. Then you explore those two different perspectives before you make your decision. So that's basically what we are going to be talking about today. Now, it is important for us to always start from the fundamentals, how we actually reach here. This is just 2025. 2025, what we are using is not something that just came up, right? It's something that is an accumulation of previous historical event. So the first thing we want to start with is how do business do their stuff before all of these fancy frameworks and all of those things comes into place. So the first thing is that businesses set up their applications. Let's say I'm issuing an insurance. So I try to build an application for people to just build, enroll, do their stuff. The application to fetch information, to populate those things, to do the processes, I keep it in a database. And it is that same database that we actually run ad hoc queries on. I've worked in a place where I think one of the federal local state government parastatals, right? So we query those software applications themselves directly. So we run our query against those DBs, right? So that is essentially what we do those days. And then we just try to like do business reporting, how much water we sold this month, this week, all of those things. So it impacts the DB directly. Then over time, we saw that the data begins to grow at tremendous pace. So it's not just because there are key drivers for data growth, right? Maybe the availability of internet, people begin to see more data points that they want to consider. Then they see that, okay, we actually need to run a lot of queries against this DB. Then that begins to clock up what we use in the application interface. You don't want a scenario where your customer is unable to process an insurance truly to the end because one BA or data engineer or data analyst is sitting down somewhere trying to eat that database as much as possible. Then what we did that time, what came up, the solution for that is that, okay, we are trying to mirror exactly what we have in our application database. We are trying to mirror it specifically in a way that we can be using that one for analytics itself. Just on the analytics, we are going to be running our query there. Then we begin to do, okay, every night when people are not using these things, allegedly, when people are not using it, we are going to be doing copy pasting the data. So we are just batch loading the record every day. Then we eat our queries again the reporting DB, which makes sense. So it solved that particular problem at that point in time, which makes sense. Then the next thing is that reports are now getting too slow. So I've been in the field to know that, okay, even though the too slow is actually something really debatable in a way that I've seen somebody describing slow and say that, you know what, my slow is that I want to see this report. Anytime I try to refresh it, it takes like years to load. That's one version of slow. Then the other version of slow is that I want today's data. It's not available there. I'll have to wait it tomorrow because our backloading have to wait until the end of the day because we process those things. So those kind of two concept of slow is what was experienced and similar to what is experienced globally. So what happened that time is that there are now solutions coming up, specifically data warehouse engines. So in data warehouse engines, not just databases now, we are now looking at it from not just batch loading, copy pasting. What we are trying to do here now is an integration process in such a way that we will encapsulate all business logics. We will like set it in a way that it can be refreshing at the rate we want, and then we consider those costs. That is, we pay for all of those fancy tools that we want to use to do that. So this is the first time where data is considered as something to be integrated, scheduled, optimized. Then we have those data warehouses where we are to run our query. But one interesting thing about data warehouses is that we do a lot of model, we have to do our fancy stuff. So all of these concepts that we just see, the kind of problem that we want to solve here, is what led to ETL. So this consideration is what led to, okay, there is an ETL concept. There is something that we want to be running that we extract the data from various sources, transform it at this point, then load it into these data warehouses because we are expecting some certain data type. We are expecting some columns. We are expecting some values here. So those things are already been predefined. Then we are just trying to run that workload at a specific timeline that we gave it, right? So ETL is born at this particular point in time. Data integration is the first touch point that we have there is ETL. And then we have a lot of tools focused on doing that particular integration as a part itself. So one of it is SSIS from Microsoft. So it's an integration service where you can use it to connect to a lot of Oracle, MySQL Server, any form of databases, even file system. Then you can be using it to run your transformation business logic. It has some tags, some packages inside that you can do. And you can even run it programmatically with C Sharp. So those things are industry focused and they have their own specific platform language, some of them, and they have specific logics implementation. And at this point, another one that I'm very familiar to that started also in that market was Informatica. That one was from IBM. So it's similar in spirit with SSIS, but a little bit very complex. And you can use it to do a lot as well. So what I'm trying to say here is that at this point, because we are trying to separate all our workloads very clearly, we that led to the formation of ETL as a service itself. Then tools begin to evolve. Everybody begin to sell data integration tools, right? And then we begin to hit our query again on data warehouses, not just a replica of what we have of our application. Then, what are some considerations that we have to look at when we are talking about this ETL as a concept itself? So one thing that I want to point out, which might be clear at this point, is that you can see now that we are now having separate integration engines, right? And then from my own experience, our own integration service instances, we dedicate a server for them, like a small PC for them that, okay, your job here is to run ETL. So anytime we want to build ETL, we build locally, each engineer build locally, then we are going to put it in that unified server where we are going to be processing it. So it added one form of complexity in that touch point, right? Then the second thing is that only transform data is being managed in data warehouse. So nothing concerns us about if a transaction is failing when I was in the bank. So nothing concerns us if we are not logging in, if we are getting, we don't, because we're not interested in reporting that kind of information at that point in time. So we already have our own concept of what we are trying to visualize, business performance, employees, payroll, all of those things. That's what is on our own mind, the business mind at that point in time. So is only those kind of data that we actually manage because we can't log into the applications DB and trying to be managing that kind of instances. We have a data governance team, right? So they were only managing wherever that we populate. And one thing that is there now is that every transformation that we do along the steps is not visible to those data governance guys. Data quality analyst is not seeing those transformations. Data analysts that we use to report, even business team that we use those things. The logic of transformation is not clear to them. It's always a black box to us, the engineers, right? So in that kind of instances, they cannot see what we did at one point to the other, except they will log into those systems and check themselves. That's even if they know those tools as we know it, right? So that also another thing that I want to point out is that retention has to be at the source system. So we are loading this data. Let's say when we started, application has been running for like 2 years before we begin to do data reporting, all of those things. The data retention is not done at that level is need to be done effectively at the source system. It's going to be like, okay, at this application level, what kind of compliance policy do we need to do? What kind of data retention do we need to do? If we delete a customer's record, how long is it going to stay before we drop those kind of instances? It's normally being done at that source level, the source system itself. So we don't want to capture that particular instances in our ETL jobs. And then the reason why people try to like do data retention is it can be compliance issues, like you are having some sort of regulation that you have to do this. Then sometime you might want to explore new analysis that okay, the data point that we are not considering before is useful to us now. And another thing is that we might want to investigate that which exactly of this information is not correct. Let's say we run our ETL jobs, they are seeing figures that they're not supposed to see, or it's very different from what they are expecting. If you want to debug that, we always go to that source system. So it's always happening, a lot is always happening at that source system because we are just bringing in transformed visuals and report for all of those people, right? So, and another thing is that we might want to try to say we are trying to maintain cost, what we need to analyze, what we desire to analyze, or even performance. So that's the reason why we want to do something like retention and all of those things. So these things that we saw here now, they are the things that we normally consider or you should consider if you're trying to build an architectural framework from your for your data integration process and say, okay, you are going for ETL processes. You should know that this is exactly what is similarly going to happen to you, right? So these are really, really important concepts that I noticed over time. Then there is now a new way coming up that okay, we are just trying to bring data from source, we clean it up, we polish it, we enrich it, then we load it somewhere. We saw that it's inefficient, that we don't want to begin to add one integration service in the middle. We don't want to be going back to the source back and forth to do data governance, to implement compliance policies, to add new decision business want to track all of those things. It's not really really interesting for us to build, because sometimes it might even crash your pipeline from upstream downstream. So there is now the question that ELT here tries to solve. What if we get everything from that source system and dump it in one place? Once we dump it in that place, everybody that wants to build something can come up from there. So that was the idea, as simple as it is. So that's pretty much what you need to know about ETL and ELT. So we are trying to say we extract these, we transform it before we store it somewhere. We try to extract this and dump it before we begin to use it. So those are the kind of things that happens between those different workloads. So we load before we transform. And what led to this, the key drivers for this is that separation of compute and storage. Before is whatever that you are using to do all your workload in your warehouse that used to handle all of these things. But now these days, you can store your data separately, and you can provision the compute engines that you wish to process the data separately. And that makes a whole lot of difference. Storage becomes so cheap. If you Google the amount of money that you are going to spend if you are saving 1 terabyte or 1 petabyte of data on, let's say, somewhere like Fabric now, you see that the cost is relatively cheap. Or maybe when you are using ADLS, or when you are using S3 or Google Cloud Storage, the storage becomes so cheap. Before, it's expensive. It's not that really intuitive something to say, I want to be dumping on my company's data in one place and use it later, even the one that I don't want to use. So compute relatively become so cheap because of that separation. Then another thing is that compute itself now become elastic. That is, you can spin up a particular process, provision that compute instance on it, and dump it. Unlike when we are dedicating a particular server and say, you know what, we have gotten this server, we have tried to like set it up. It's going to be here processing this job anytime it comes, or when we want to use it or whatever. But now compute become elastic and is on demand. Is when you need it to spin it up. If you want your pipeline to refresh the data now, spin it up, pay for that small time, then cut it all off. But it's getting expensive these days because some engineers, I don't even want to say some engineers, right? The concept of trying to process something on compute, when you have like, let's say, 1 billion records now, and you're now trying to do update on those records, and you are doing merge insert or merge whatever that you're trying to do, then you are not partitioning the ones that you need alone. That means you are going to be running your merge insert. If that particular platform is not self-optimized, you are going to run merge insert on 1 billion record, which is not really interesting. You are going to pay a lot for that. So you should take care of that one as well. Then the third driver is that the evolution of data lake. As I said, those storage became really, really cheap. And then the last one is that business wants a seer. As I said, that data is an asset, right? Everybody wants to tap into this asset. You before is always business as usual. How much money do we make? How much money do we lose? What is our customer increment over time or whatever? But now people want to see that how many people logged in yesterday that were unable to do transactions. You can see the complexity get like a little bit deeper. That is, business even saw that they can know a lot from their data. So it's more of like, if you're an analyst, you should be a seer. You should be able to tell things that are not even possible, right? So complexity of business requirements gets very deeper. So that is why people now see that, okay, this is not scaling. We can't be going back and forth to be adding new data points and all of those things. Let's just dump. Whenever we dump, we know that that data is available, then we begin to process that, and that's it, right? So those are the things that come to mind when you are looking at ETL workload itself. So at this point, let's try to maybe bring it all together to separate those two workloads or architectures. So ETL is the we're trying to give the process an input, which is, okay, take this set of data, run some things on them, then load them somewhere. They want to use it to build report. Then the other one that we want to do on the other side, which is ELT, we are giving it an input. It creates an instance of that input again. Then that means we already dump it. We are dumping our input. We give it an input, we dump our input. Then it's from that input that you begin to transform and you create an output. Output can be maybe ML model, anything that you want to do. But the important there is that there's a layer of input duplication, right? You have it on the source system, then you have it in your maybe lakehouse or warehouse or data lake, wherever you want to keep it, or even object storage, right? So another key thing to that separate those two workloads is ETL is schema on write. Is when you are trying to write those things into the data warehouse where you store them as part of your transformation process, you ensure that those schemas merge, or you make sure that they are in sync, right? But one thing about this ELT is that you can do schema on read. Is when you want to read the data that the schema is being considered, you are just dumping. Your own is just to dump, regardless of whatever the schema is like. So, but in ETL, you already build your models and all of those things, right? So now, upfront development, for you to do ETL workload, your endpoint must really be clear at some point. Like, okay, it might not entirely be clear, 100%, but you should get something correct up to like maybe 85, 90%. That this is what we are trying to target, this is what we are trying to look at. But in ELT, you don't even know what you want to do. Then you begin to dump a lot of things. I don't know if I'm going to use login credentials. I don't know if I want to use this one. Just dump all of those things. And that's like one of the risks associated with ELT that we will see later on. So we can see that these two concepts, even though they are a little bit different, we are trying to solve the same problem. We are trying to give output to the business. It's as simple as that. We are trying to do the same thing in different contexts. And what we are trying to do in different contexts is that we are trying to find the best position to place our T in between those three things. So you are trying to optimize for the best position to put your T. And then believe me, there is no standard rule that you have to place your T here or you have to place your T here. But there are some things that comes to mind when you want to make that decision. And that is what really makes good engineer, right? It's not just because you can write C# or whatever, it's because you can actually solve problem and then really decide when trade-offs come in. That is, you know the reason why you are doing this and you can defend that. That's a very good policy of any engineer or architect. So let's see the benefits and then the drawbacks on those workloads. In ELT, right now, is that we run transformation with SQL. So most of the things, most of the platform that provide these kind of workloads these days, they make it in such a way. I've analyzed a lot of them. You interact with them with SQL. Unlike when you are working with SSIS, if you are very good with Visual Basic or you are very good with C#, you will get complicated stuff done. Like not everybody is familiar with that. Not everybody that is a data person is really familiar with C# if they are not very, very committed to learning it, right? But I think I learned C#. That was my first programming language. I learned C# as my first programming language. So I didn't have issue with exercise, but not everybody. As a matter of fact, very small percent of engineers really know C#. They prefer Java, Python, and all of those things. But this environment of ELT these days, they are built in with the lingua franca of data, which is SQL, right? And then another thing is that retention is managed in the data store. So you can do your governance team will be able to see all the data that is needed and they can properly govern it, right? So everything that is needed is being considered there. Retention dropping is being considered there. They don't really think about it that much again in the source layer. They still think about it, but not that very intense. Now, the second thing is that you cannot track the lineage because the lineage is not happening in the source system. It's already happening within the warehouse itself. So they have a dump of a stack of data for you, and you build a, let's say, a particular project with it. Then, if they want to investigate what you did, they don't need to go into an external environment. They just need to see your workload in that particular environment itself, which makes sense. They can track what you use to a particular source, that this is what you use, right? Then the second thing is, then the next thing is that you can replay transformation. It makes sense that business wants more thing. They really want this, they really want that as an addition to what we were doing before. You can replay those things because data is directly available in that environment. You don't need to be racking your head that I'm going back to connect to the source system. And then another thing is AI focused. That dumping of data, that huge stack of data that you see there, is really what those big tech companies are leveraging to build big base foundational models. So that is what they use to build all of these things out. Is AI focused? ELT workload these days is really, really accommodating when it comes to AI focused or AI based foundation in an enterprise, right? Because you have access to pool of data, then you can use it to do all of those things. So let me give an instance here. It was more of a challenge for me to build a classification model then in Nigeria. So it was really very difficult because I have to be going back and forth with some source system. We don't really have a central, maybe a lake or a data lake, right? But as time goes on, those new platforms that they are building, that they are dumping all the information that I need there, it's easy for me to do try and error, go back and forth. So it's really, really AI focused. I can even say ELT is a AI native architecture, right? Then there are some drawbacks that you should be considered. Some things that it might not be true for everybody, but one thing is that beware of data or vendor locking is really, really a critical problem. I think I faced this problem lately, right? So one thing that happens there is that let me give a very specific example. Is that you see Microsoft Fabric, right? They will come out and be saying this is data that we are storing on Fabric. It is open source format. It is Delta Lake. It is Parquet. All of those things. A lot of people don't really know what that means, right? They don't know how powerful that is. If you are using a particular vendor, that once you dump your data there, that's it. You cannot send the data to another platform because the algorithm or the way the data structure is being stored in that environment is not going to work in another platform. Then you are locked in with those guys. It does really, really a big trouble. I know someone in Starbucks that we like consulted together. So the person was saying that one of the worst problems that you will have is going to be you having data or vendor locking. That's like a really bad spot to be in, right? So when they say that this is open format that will support it, it means you can teleport your data from that platform to another place very efficiently, very quickly. You don't need to think too much about it, right? Compared to when you have to call the company, you have to do a workaround. That's even if that is possible, right? So beware of that. Another thing is that compute isn't cheap. You have to be really, really spend some time to understand how the compute system of the platform that you are using is being charged. So that you won't just come one day and say that, okay, you have maxed out all the department budget, right? Compute isn't that cheap, it's not friendly in such a way that if you try to like process a lot of things, you might crash whatever that you are using to process it, right? So, and then the next thing is that it is perfect for batch load. So let's say something, I think I know that most of the systems in big tech companies, they dump into a lake. Like they took snapshot of their databases at every point in time. They dump it inside a place where they begin to use it, right? So it's very efficient for batch loading, especially when your data is even big. You are working with big data. So it makes sense to be dumping, take snapshot at every point in time, then dump it. And that's really, really well, very impressive. But it's a drawback because if something is too focused on one particular kind of experience, it means that it won't really scale well, except you do some conic stuff, right? In the other side, which is streaming stuff. So if I want to do streaming data reporting or data analytics project now, I'll be thinking more of ETL rather than ELT. Then it is easy to be a swan because we are trying to just capture a lot of things. Believe me, in 1 month, that place will be a mess. And then crazy thing is that 99% or less than 90% of this data that you are dumping might not even be used at all. So always avoid that kind of scenario where you are just dumping, but it might not really matters because I said storage is cheap, right? But you might want to rethink the way you do things. And it's not just because of cost perspective, it might really be a noise, a distraction, because it's really not needed sometimes. So it's always very easy for you to be a swamp. A lot of things can just be there, both what you need and what you don't need. They clog up, and then you lost track of things. And then ETL on the other side, the benefit here is that only clean data is what we are managing, which is quite impressive. I really don't care so much about whatever that we have that is coming or not. It means that our idea will properly be formed very well when we are doing ETL focused approach, right? A project that goes on with ETL approach, they are always something that kind of like have definitive endpoints. So only transform data is being considered as stuff, which really is a no stress lifestyle for engineer. And then another thing is that same data for everyone. Most of the ETL workload, they are being used to populate something like a data warehouse or a data mart, data mesh, all of those things. So what they do here in that ETL workload is that you are confident that everybody can see the same data. Unlike when you just pick one something off the shelf from your lake house, you pick something off the shelf, you use it to be something for another person. The same person might request from another teammate of yours and also pick something, the same thing, and then get different outputs. But when you are using something that is that standard, you expect to use the same data for everyone, same input, same output kind of things. Then the drawback to this is actually an added maintenance overhead and then complexity to develop. So you think so much when you are trying to build a warehouse compared to when you are building a lake house. You just begin to dump. You are already there. You begin to dump. You are there in your lake, in data lake. But when you are talking about um, a warehouse, you have to be thinking ahead. Okay, how am I going to model it? What are the things that am I expecting? What kind of stuff do I do? How like this data should come in? That is your target will already be clearly defined. And clear definition or accurate definition of a future occurrence is not really something that is always true. So most of the time it can be correct, but it's not always correct, right? So those are like the common drawbacks that I've seen and benefit. And then again, it's not like you just come when you want to build your project, you just run it through this benefit or cost. It's just a direction to see that okay, we actually think about this in a very good and then high level way, so that you can see that we're not just following the trend. We're actually thinking about these decisions critically before we proceed with whatever we want to do. Then the next thing is that what's the implication of all of these things that we are talking about? A scenario where we will do ETL jobs, ELT jobs. What's the implication on us, right? First of all, it's creating an opportunity. That's what I would love to see. Is an opportunity for almost everybody. The shift from ETL to ELT. So you can see that is driven by what is expected these days. Most companies want ML models. Most companies want to build AI stuff. That is why ELT is shining these days. Because you need huge amount of data from different things that you can consider together. And data scientists love it when they have so much data at their disposal, rather than just me building ETL for them every time they want to consider some stuff. Why can't I just give them access to a lot of things? Let them just see and then combine, do all of those things that they want to do. So AI is one of the major driver for ELT sales these days, right? So it's creating opportunity in such a way that we are now moving from ETL developer, which is like me focused on building warehouses, structure, data platform, and all of those things, is now making me to think as a platform engineer. So we now have data platform engineers, right? In such a way that you have to understand how to set up a lakehouse, how to set up a data lake, how to set up this one, right? So it's making you to think about cost. It's making you to think about how server works, how compute engine works. So it's evolution of roles. An evolution of roles to me is always a possibility to gain into a developing market, right? So you might be focusing on, okay, how do I build a data platform, reporting platform on GCP or AWS? So we are moving from ETL developers to platform owners. Another thing is that we now have software best practices in place in such a way that because of this change in approach, we are being forced to do something like, okay, test your ideas when you are building something. Like, okay, I'm trying to dump this data here and I want to build these things. As you are building it, because there is element of we getting the same input but different output, let us test some things, right? So we do a lot of unit testing, modularity. We try to make sure that the pipeline is idempotent itself. That is, if we run it today, yesterday, tomorrow, previous month, we are going to get the same results. So far, we give it same output, we are going to get the same input. We are going to get the same output, right? So software practices are being preached more now, and then the next thing is that the test stack is actually getting elongated, it's getting stretched. That's like a stress point, right? For people that are already in data, might be opportunity for people that are new. So you have to learn beyond your SQL, you have to think about BigQuery, you have to think about Snowflake, you have to think about Parquet files, you have to think about how Parquet files are being worked on as a Delta file, how data file is being used as a Delta lake. Data table. All of those things are adding complexity to the tech stack that is required for an engineer or analytics engineer or data analyst, right? And then one critical thing there is that analysts are now more empowered. Before, I can just give you a table with hundreds of columns. Now you can begin to investigate yourself and see that, okay, since we have a data lake, let me try to see what's happening there. So now analysts are being empowered to do more. And that's why we are even seeing something like analytics engineer, people from data analysis field, right? They try to like go to analytics engineering because they know more about the analytics part, and they now have the opportunity to become an engineer. So because data is being provided to them, so they are empowered more, right? But they don't have to think about that high level GCP package file, but they have the option to go and get something from a particular storage system, right? Which makes sense. So they are being empowered more, and that's, I think Fabric is doing more of that now. If you're a fabric engineer, you can become so many things so many times, right? Very quickly. You can become data scientist. All of a sudden, you can just think that you want to be an engineer. Those platforms bring things together, then you can do more. And the last thing is that beware of cost base, complexity, and governance. It's very easy to say that, okay, you're trying to do all of these things. They are very fancy, they are very good, but you have to think about it from your employer's perspective. Are you trying to cost them more? What's the value of what you are doing? Always try to size the value of what you are doing before you do it. And then don't make it too complex, right? If you make it too complex, it's going to really be a painful part for you so far you're in that company, except you resign or join another place. Then the governance, think about the governance part, right? If you are dumping data from a source system and you are dumping inside a place, in another place for you to later use, you know that and not everybody is supposed to see this, let's say, card pin or something like that, but you already dump it there. How do you protect that kind of things? So you need to think more about that governance. So sometimes ELT can come as e small t. That is, as you're trying to extract the data from the source, you just drop off some columns or you encode some parts before you dump it, before you begin to dump it, right? So always think about that. I've seen companies getting sanctioned for that before. So always like it's real. So it's always very important to think about that, whichever architecture that you pick. But specifically with ELT, that comes with it, right? So look before you leap. The summary of what we are trying to say here is that it's very good that we know that this is what ETL is like. These are some use cases around it. These are benefits. These are drawbacks, as we have discussed before. One thing that you should first know is that ETL or ELT is not all or one. That is, it's not like, okay, anytime you have to make that decision. You have to think about the context of what you're trying to do, the kind of problem that you're trying to solve. Like, okay, I am trying to solve a problem where I know that the requirements are not that clear, or I want to see what we can achieve specifically even when it's AI now. So you have to spend more to ETL that point in time. Or let's say it is just a small project that they just need to report something and it's clear at that point in time. There's really no point in you stressing yourself. Just run the ETL maybe with Power Query alone. So just do your stuff and then move on with it. So it's not all or one. You just have to put context. Context really matter a lot. Then the next thing is you have to understand the business perspective and then the projection. This one speaks to like people that are in the that are not just junior associates, they are more of like senior persons. So you have to think with in line with the strategic vision of the company in such a way that, okay, for this particular company, what is the management trying to achieve in the next 10 years in terms of analytics, right? And if you see that, okay, they are trying to create some strategy to be cloud focused, they are trying to be more AI focused, they are trying to be more predictive analytics focused, then you should be thinking that, okay, this ETL version that we are trying to do now might not really scale at the end of the day. Let us begin to transition to ELT. Or if you see that, okay, they are more of a traditional this thing, then it's all good. There's no need to add complexity to the workload. Or you see that the teammates there, they really don't have that technical strength to carry on with your fancy architectures, right? So you might want to consider those things. So it's very good to align your decision that you are making with the strategic vision of the business, right? Then you do trade-offs. This is this is the best part, right? Where you are being given options, but you're able to look at what you have, your options, and pick the best part, right? And how to do that is that so most of the time where I get to make that kind of decision that am I going to build an ETL for this kind of business domain. So our own is that we have business domains, right? Like big business inside the business. So we call them BUs, business units. So those business units, when they want to like build their own flesh out architectures, I always decide, okay, am I trying to like what are the tools that are being presented to me? What is the company paying for currently? What's the cost of all of those things? Which one is easy? And then how frequent is this going to be happening, right? So I use that kind of information to make my decision and say, okay, I'm going to go for ETL. I'm going to go for ELT. So most of the times, I won't lie, I used to go for ELT. But it's not a sales point for ELT, right? It's kind of like very easy, very easy, very straightforward, and then the timeline to complete that is very short. And another thing is that you have to actually be very creative, right? Creative in the sense that you need to study deeper. There are ETLs and ELT are like the global baseline architectural frameworks. Low level, there are more important stuff that will drive the success of those two architectures that you see. So some people might decide to go for ETL, but they write their query in such a way or their logic in such a way that if the system fails, it go back to correct those errors and populate the right one, the duplicates, do all of those things efficiently, right? And then it's automated. That kind of scenario is not just decision of ELT or ETL. The person knows how to scale pipeline processes. If you really don't understand how to scale second tier pipeline processes, that you know how to build some more complicated levels, right? Let's say you know how to do maybe data compression. So there was a time when I was trying to like compress, I think almost 3 billion records to like 24 million records, right? It makes sense. It wouldn't have made sense for my ELT process, ETL process, But since I was able to like compress that and make it like very good that way, and it works very well with ETL. I didn't need to go to ELT and be dumping those records and all of those things. So you really need to be creative and know how to combine other things that you have, right? Then the last thing is that be realistic, please. Know your team strength, know what you know, and then always try to learn more. So there's always room to learn more, right? There are always companies that are providing these things. They talk at a very low level about what is going on with their platforms, right? So always try to make yourself available to learn, to develop. It will not come all at once, but you will just be growing those things small, 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 small. So if you pick like let's say Fabric today, now you can begin to learn each aspect of it, not just overview of what is going on. Find out that okay, if I put in a file in a lakehouse as a package file and I try to like turn it to a delta table, what is actually being processed there, what is going on. You will see all of those things in those in the file system. You will see everything is there. You have to just read documentation, be realistic about what you know, be realistic about what you don't know your colleagues, what their strength is before you make those decisions. Don't be a problem to everybody, right? So that those are the kind of things that comes to mind when you're trying to decide. And my advice is that this is 2025, right? AI is a thing. AI is a thing means that you have to. AI is not something that is very, very certain about what you are going to need as an input. So it's very good of you as an engineer to see now that how can you be scaling your workloads towards ELT. That's what my own personal bias is going to be all about. It's very good when you know how to scale your ELT processes and see how you can get the best of it. Over time now, you will see more companies going to be AI focused solely. AI native companies will be coming from Africa, from Europe. I think they are very good here in Europe, right? So you will see more of them coming up over time. And if you are not ready for this, it's not really, really good, right? So try to balance things out, understand the core things that is happening in ETL, then try to push yourself towards ELT, see those varieties of tools that you have there, maybe cloud focused or local, how to set up all of those things locally, right? So that's like my advice for anybody that wants to do data engineering in 2025. Those two architectures are important. Try to stick with your ELT as much as possible, right? So because I don't want to be one of those consultants that I will tell you that it just depends. Most of the time, it will always want to fall into ELT. Most of the time, sorry. So that's my experience there. So thank you. If you have any questions, we can just proceed to answer. Thank you.